Hi, everyone. Just wanted to take a minute to talk a little bit about the area of circles and sectors, which is the next step on the kind of area uh, journey that we're taking. In terms of area of circles, that's probably one that you're relatively familiar with. That is pi times the radius squared. And in case you are curious as to where this comes from, the same thing that we've been doing this entire time, right? We're going to break it into triangles, see if we can use that to derive it. And actually, as it turns out, you can if you break it into triangles. Um, so as you can see here, you break it into triangles. Each of them, has a height of the radius, right? So that's actually the radius. So each of these has a height of r. Um, and the red is kind of half of the circumference, and the blue is the other half of the circumference. So essentially, this right here would be half the circumference, and the circumference is 2 pi r, right? So this is 1 half 2 pi r. So those cancel out, and you get pi r times r, right? So, and if you keep, cutting it up into smaller and smaller and smaller and smaller and smaller triangles, you get closer and closer and closer and closer to a parallelogram, which is why we approximate it by doing r times r, right? So it'd be r squared times pi. Um, and that is where ultimately the area of a circle comes from. Now, there's two examples here. So if we were to find the area, if you left it in terms of pi, so the diameter is 14. So the radius is 7. So the area is just going to be 49 pi feet squared. Okay, this one over here is 12. So the area is 144 pi centimeters squared. Now, if it doesn't ask you to approximate, please leave it in terms of pi. That's a more exact answer, and there's no need for you to plug it in if it doesn't specifically need it for some reason. All right. Now, the part that you might not know is something called area of a sector, which is, imagine we just took part of it, kind of like one piece of that triangle, if you will. Now, obviously, the area is right here in this formula. Now, this right here is basically saying we're taking the measurement of the arc, or it's the same thing as the measurement of the angle. So sometimes you'll see it written as the angle. They're the same. Doesn't make a difference. So the angle measure and the central angle measure and the arc measure will be the same. So sometimes you see it written as theta because that's usually the angle we use. So we're saying essentially we want this fraction of the whole area. So we want this area amount based off of this fraction. And we know the whole circle is 360 degrees. So to find part of it, you would just do essentially the ratio. If we have n degrees, like if it's 120, that's a third of the circle. If you had 60, a sixth, so on and so forth. So you're really just finding the percentage, if you will, of the circle. Okay, so let's set this up. So it tells us MHK, the measure of angle HJK is 126, and HJ is 20. So that's our radius. So find the area of sector. So area is going to be the angle 126 over 360 times 20 squared times pi. Now we can, let's see, what can we simplify? This is 2, so that'd be what, 63 over 180 times 400 pi. Now, let's see, can we simplify this anymore? The 0 is going to cancel there. That's fine. Oh, this is 9 times 2. So the 2 is going to cancel here. That's going to make this 20. That leaves us with a 9. The 9 and the 63 actually cancel, and that just leaves us with a 7. So what's 7 times 20? Oh, well, it's 140 pi. I almost forgot my units. Squared. Okay. So that's just simplification. Again, leave it in terms of pi if you can. One more just for good luck. This is telling us that the area of the sector is 18 pi. And it tells us the radius is 9. And it wants us to find the angle. So I'm just going to write theta because I don't want to write the whole angle out. 360 times 9 squared, which is 81 pi. Obviously, the pi is going to cancel, so we don't even have to worry about it. Now, let's see. What can we cancel? 360 would be what? 9 times 40, I believe. So, yeah. So 9 times 40. So we have 18 is equal to pi over 40 times 9. I'm going to divide by that because I don't want to deal with it. So if I divide by the 9, that would give me 2 is equal to theta over 40 times 2. So theta, or the angle, which tells us is this angle. Again, I just don't feel like writing the whole thing out, so I'm just calling it theta. Is 80 degrees. And there you go. So that's everything about area of a sector and area of a circle. It's hopefully just kind of knowing how to manipulate the formulas. You also will be benefited if you are pretty good with identifying factors and simplifying. So if you are struggling a little bit with that, make sure you do kind of look at some factors to help you out. But let me know if you have any questions, and have a great day.